Saint-Laurent-sur-Mer, France, 19th of June, 1944. White surf hammered steel pontoons off Omaha Beach, the American landing zone in Normandy, as cables screamed. U.S. Navy Seabees, naval construction battalions, watched moorings part. One engineered harbor stood between a new beachhead and a sudden shortage. The Mulberry Harbor, a prefabricated artificial harbor assembled offshore, faced its first real test. Behind it lay an armada of over 7,000 vessels, yet unloading demanded calm water. 2 Mulberries answered that need, one off Omaha, one off Arromanches to the west. This is how a 3-day channel storm broke the American harbor, how the British one survived, and how Allied logistics bent, not broke, to keep the invasion moving. Off Omaha Beach, Normandy, France, 18th of June, 1944. Gray swells lifted steel and concrete like toys as crews tightened lines. The makeshift harbor off Omaha stood between a growing army and an empty pipeline. Its promise was simple: behave like a port before any port existed. 2 such harbors were planned. The American one, Mulberry A, a prefabricated artificial harbor assembled offshore, lay off Omaha. The British counterpart, Mulberry B, rose off Arromanches under bluffs that offered some lee in westerly weather. The outer screen did the first hard work. Bombardons, a steel floating breakwater, rode at anchor to blunt incoming waves. Behind it, Phoenix caisson, a massive concrete box sunk as a breakwater, formed a rigid wall. Closest to the surf was the Gooseberry, a line of scuttled blockships that added deadweight shelter. Omaha's open bight offered little natural protection against long-period swell, the slow, heavy waves that carry far and hit hard. Inside that man-made quiet, ships met piers that could rise and fall. A Spud pier, a floating pierhead on adjustable legs, kept the berth steady as the sea moved. A whale roadway, a steel floating bridge, reached from pierheads to sand. Beetle pontoon, a buoyant support under whales, held the bridge up through the heave. It was a kit assembled under fire, then nursed through the tide. The traffic it handled looked ungainly but solved problems. LSD landing ship tank, a 328-foot vessel delivering heavy vehicles to beaches, could nose into a Spud and offload without grounding. LCT landing craft tank, a smaller tank carrier for nearshore shuttling, ferried loads from anchorage to pierhead. Duck, a 6x6 amphibious truck, moved cargo from surf to dumps inland, crossing where a road did not yet exist. Normandy's tidal range reached about 20 feet 6 meters on spring tides. That rise and fall could strand a conventional pier twice daily. The Spud legs answered by holding the pierhead at a fixed height as the hull rode up and down. The whale distributed loads and flexed, so a truck shuffled onto shore even as the sea breathed. The seabed forced compromises. Sands shifted under propellers and surf, smearing survey lines within days. Engineers drove piles where they could and accepted that some moorings would drag. They designed for damping, not perfection. Each layer of barrier took energy out of waves. Even a small reduction meant cargo came ashore faster, with fewer broaches and fewer damaged vehicles. By mid-June, the Phoenix units off Omaha stood in position, their tops awash at high tide. Lines of whales linked the Spuds to graded beach exits. Mulberry A loaded and unloaded in cycles, a mechanical tied atop the natural one. Early throughput included vehicles, artillery pieces, and fuel in jerry cans, the squat cans that fit anywhere a drum would not. The human system mattered as much as steel. Seabees, naval construction battalions, built and kept the pieces aligned. They coordinated with U.S. Army Engineer Special Brigades, beach logistics units, who ran the flow ashore. Traffic control teams marked lanes, flagged LSDs to assign pierheads, and routed vehicles along taped corridors off the beach exits. Inland, details guided ducks toward dumps and refueled them for another circuit. Meanwhile at Arromanches, Mulberry B took shape behind a headland and a firmer seabed. The British set more Phoenix in a tighter arc, trusting the geography to finish the job. Omaha had no such help. Its strength would be what men could anchor, weld, and keep aligned in open water. On the morning of the 18th, Mulberry A worked but remained incomplete. More Phoenix waited offshore, and additional whales and beetles were still under tow. Cherbourg, the nearest deep-water port, had not yet fallen. When it did, German demolitions would choke it for weeks. The plan accepted that gap. The artificial harbor would carry the load until a real harbor opened. But the channel kept its own schedule. A low brooded over the water, and barometers dropped along the coast. Wind rose before sunrise on the 19th of June. Whitecaps thickened into long, slate lines. Swell pushed in, faster and heavier with each set. Mulberry A stood in that gray light, its pieces creaking, its promise on trial. If it held, the beachhead kept breathing. If it failed, a growing army met empty shores. The English Channel looked narrow on the map, but it punished structures. Short fetch. The distance wind blows over open water, built steep waves quickly. Refracting shoals, shallow banks that bend wave fronts, focused energy where planners wanted quiet. Tidal currents crossed the wind and scuffed the surface into chop, moving two directions at once. A clean swell met a confused sea, and the result struck harder than either alone. Forecasting in 1944 lacked the eyes now taken for granted. No satellites watched cloud tops. No buoy network streamed live wave data. Meteorologists read ship and shore observations, drew isobars by hand, and ran simple barotropic charts. They warned of unsettled conditions, squalls, and poor visibility. They did not predict a persistent gale with periods long enough to chew through defenses. A slow, deep low moved farther south and lingered longer than expected. By dawn, gusts topped 40 knots, climbing to full gale on the Beaufort scale, wind force scale from 0 to 12. Orientation mattered. Omaha lay on an open curve, with little relief from headlands in a westerly. Arromanches sat behind the Calvados bluffs, a geography that took some bite out of west-running seas. Long-period swell waves generated by distant winds wrapped around the headland, but lost height. Over the Omaha approaches, the same swell steepened as it met bars and a gentler bottom slope. Breakers over 3 meters, about 10 feet, marched across the near shore and carried farther inside. The outermost defense took the first hammering. Bombardons were new steel floats intended to spoil wave shape and bleed energy before it reached the Phoenix line. They held on multi-leg moorings with heavy chain and swivels. In crossed seas, they yawed and surged, loading each anchor line differently from minute to minute. Slamming, the sudden impact when a hull met a wave face, sent shocks through their frames and into connectors. The design tested well in short blows. Few had seen it work under day after day of hard, oblique seas. Inside that ring, each layer coped with a different kind of punishment. The gooseberry of blockships knocked down chop, but it did little to stop the long, heaving lift of swell. That motion rode in and worked on everything moored or piled. Phoenix caissons depended on settled sand beds and balanced ballast. Scour ate away at their toes as current accelerated around their sides. A sage, a standing wave in a semi-enclosed basin, set up between lines, gently at first, then with more authority as the low held. Small changes in water level, out of phase across the harbor, tugged caissons unevenly. The pierheads fought back using clever geometry. Spud legs dug into the seabed and held the pierhead at a fixed height while the hull rose and fell around them. That only worked if the pad stayed supported. As sand blew out from under one corner, the leg racked and sometimes jammed. Whale spans flexed between hinges meant to take pitch and heave. On this day they took torsion as well, twisting when one end rode a crest and the other sat in a trough. Pins elongated. Rubber bushings squealed. Beetle pontoons slammed and rebounded, passing new shocks up the spans. On shore, the beach group saw it coming. Bulldozers cut low berms along the backs of the dump areas. Fuel and ammunition stacks shifted to higher ground. Jerry-can pyramids were roped together and braced with spare timbers. Traffic control routed ducks away from depressions already filling with blown spray and runoff. Engineers dragged out more anchors and rigged guy wires to brace whales against yaw. A kedge anchor, a smaller anchor used to reposition or steady a vessel, went into any patch of bottom that held. Each added line helped, but reaching the work grew dangerous by the hour. Reports started to crackle over radios from the outer roads. A bombardon had parted a mooring to the north and slewed down sea, still attached by one chain. Another dragged both anchors and ground toward the Phoenix. Tugs tried to get lines aboard and failed in spray and flying chain. A towing bit tore loose. Men on the breakwater scrambled to clear fouled lines while standing waist-deep in surge. In the gap between sets, it looked manageable. Under the next white wall, it did not. By late morning, the scoreboard turned. The first failures appeared in the outer line, just as the tide shifted and the sage grew stronger. A loose bombardon struck a whale span end-on and bent a connector. Elsewhere, a Phoenix settled a few inches off level as sand slumped from its base. Inches became a foot as the tide fell and pressure lines changed. One spud leg stuck high on its rack while the others traveled. The pierhead listed and could not be leveled. LSDs waiting to use that berth stood off and took green water over their bows. The question hung over every decision. Could Mulberry A ride out a multi-day pounding? It had been built for shorter weather for the squalls and blows common in the channel. Now duration mattered more than peak. Every joint saw more cycles. Every line chafed longer. The outer layer's gaps fed bigger seas into the inner works. The storm had not yet peaked. More wind, more water, and heavier sets were still inbound. Late on the 19th of June, 1944, the outer line began to come apart. Bombardons broke adrift and rammed whatever lay downwind, steel riding steel until something gave. One parted and drove its corner through a whale span, holding the box girder and flooding the buoyancy tanks that kept the roadway level. Others swung on fouled chains, dragging anchors into tangles that loaded every shackle to breaking. Tugs closed to help, then fell off. In the next crest to trough, towing lines snapped under shock loads. Inside the ring, the heavy pieces trembled. Phoenix caissons vibrated as long-period lift worked against their sheer faces, and the water accelerated around their sides. Scour pits deepened along their toes, sucking away sand and leaving voids where ballast had assumed support. A few settled unevenly and cracked along stress points, opening seams that wept air and admitted water. Each inch of subsidence opened a bigger gap, and each gap let taller waves through to punish the works behind. The pierheads felt it in their bones. Spud pierheads yawed, their legs punching into softening sand on one corner while another rose high on the rack and stuck. With the angles wrong, hinges fought the sea instead of flexing with it. Seabees hauled out cutting torches and severed disconnected whale spans before they could lever entire pierheads over. It was triage. Sacrifice a roadway to keep the pierhead from rolling. Chaos spread on shore. Pontoon causeways tore loose and piled onto the beach like matchsticks, steel boxes stacked by blind surf. Engineer special brigades cleared beach lanes between squalls, shoving wreckage aside with dozers so convoys could escape the flats before the next set. They flagged off low ground already turning to pools and moved signal panels to higher sand. Hand signals replaced radio calls when spray smothered aerials. The ships under orders to unload chose preservation over schedule. Several LSDs beached intentionally to save their hulls, edging in at high tide to ground safely rather than risk a failed approach to a heaving pierhead. Crews set anchors to seaward and waited out the worst, engines ready to help when water returned. Out in the surf line, ducks capsized in breaking waves. Shore parties fired lines or simply waded out in teams between sets to pull drivers in. Every rescue cost minutes and men who could not be spared elsewhere. Through the 20th of June, the sea refused to ease. More Phoenix shifted off their marks. Their proud tops rode lower, and the rank of caissons no longer read as a straight wall. Small coasters in the outer roads dragged anchors until they fetched up broadside in the surf zone, where they took the full hit of each breaker and added to the field of hazards. Ammunition stacks went inland another 100 yards. Loose fuel drums rolled like driftwood and were corralled behind hastily built berms. Salvage parties worked between sets to cut away snarled chain and clear shattered beetles from the roadways. Communications faltered as aerials and field lines went down in spray. Runners carried short notes that were soaked before they reached the next tent. By nightfall, the damage spoke plainly. Pierheads twisted against their legs and could not be trued. Pins elongated, some sheared. The neat geometry that made the system work now worked against it, translating every offset into a lever arm the storm could use. On the 21st of June, engineers walked the lines where they could and sketched what they could not reach. Their assessments agreed. Mulberry A was structurally compromised. The pattern on the charts matched what men saw with their eyes. 3 days of pounding left whale roadways broken or missing, pierheads skewed, caissons out of alignment, and moorings wrecked beyond quick replacement. The outer defenses no longer bled enough energy to protect what remained inside. Even if parts could be patched, the system as a whole no longer met its design. It was a harbor only in name. On the 22nd of June, commanders made the call most had already reached in practice. Mulberry A was beyond economical repair. The pivot was immediate and pragmatic. Abandon the harbor works and shift to direct beach unloading. LSTs, LCTs, and coasters would ground on planned tides, discharge across their own ramps, and back off with help if conditions allowed. The beach groups reshaped lanes, marked new turning circles, and treated the waterfront as a variable frontier rather than a fixed port. Meanwhile, attention swung to the west. Arromanches lay under the same sky, but behind different ground and different lines. If one harbor had failed, could the other carry the load? The answer would decide how the invasion fed itself in the weeks ahead. Arromanches sat under bluffs that mattered when the wind veered west. The high ground broke low-level flow and altered how long waves approached the works. The seabed helped too. Chalk and firm sand under the Phoenix line made scour slower and more predictable than at Omaha's mobile bars. When warnings spread, British commanders ordered extra blockships scuttled to thicken the gooseberry. That hedge paid off hours later. Bombardons parted here as well and drifted in dangerous arcs, but most were hurted or cut away before they could punch through to the caissons. The crews used every lull. Royal Engineers and Royal Navy parties dropped additional anchors on crisscrossed leads to restrain yaw at pierheads. They packed sandbags and laid timber under Spud footpads to spread load where the bottom softened. They added fendering, protective bumpers absorbing berthing impacts, to Spud faces, lashing tires and balks to take the shock of a heavy ship heaving against steel. Whale hinges were inspected by feel and sound. Hot rivets and replacement pins rode out in small boats the moment spray thinned. Damage was heavy but tended to stay local. A broken whale span might isolate a single pierhead instead of unzipping a whole line. Repair units had rehearsed swaps. Spare sections lay on beetles nearby, with tools packed by task, not by owner. Divers marked fouled chains and cut them free. Tugs nosed loose bombardons toward clear water or sank them outright when a tow threatened more harm than good. The caissons groaned and some settled inches, but most held their geometry and kept a behind-the-wall calm that Omaha lacked. Within days, operations resumed, smaller, slower, but steady. The harbor earned a nickname that stuck. Port Winston, a nod to the Prime Minister who backed the idea when it sounded far-fetched. Early throughput came at reduced capacity. Lighter loads per approach, fewer berths open, stricter limits on sea states. Each day, a few more spans went back, a few more anchors bit, and a little more confidence returned. Crews learned the rhythms of the altered basin and worked to them. Arromanches took coasters, small coastal cargo ships, alongside and kept LSTs working the Spud pierheads. Improved fendering let ships ride out surges without tearing plates or springing seams. Pilots, mariners who guide ships into port, refined approach lines to avoid cross-set where the breakwater gaps bled chop. Ashore, traffic circuits shortened, and loading parties staged cargo in cleaner stacks to cut dwell time at the pierheads. Each saved minute at a berth, added dozens of tons by nightfall. By early July, the harbor often moved thousands of tons daily, roughly the output of a pre-war regional port. Ammunition, engineer stores, and petrol, oil, lubricants flowed in mixed streams tailored to immediate needs. As Cherbourg choked on demolitions, American planners asked for space. When the sea allowed, U.S. cargoes shifted to Arromanches berths, especially high-value or time-sensitive loads. It was not ideal. British and American handling methods differed, and paperwork lagged reality. The calculus was simple: better a longer drive inland than a ship idle offshore. Behind the scene, coordination nodes earned their keep. Naval officers in charge at each beach met twice daily with beachmasters, naval officers directing beach traffic, Army movement control, and tug masters. Berths were reallocated on paper, then by colored panels and signal lamps. Pilots shifted between sectors in small craft. Tugs sprinted where they were needed most, sometimes dragging additional kedges to stabilize a hard-used spud. The goal was frictionless handoff. An LSD that missed a damaged berth at one sector should find a live one at the next tide across the bay. Lessons accumulated with each tide. Mooring plans grew redundant. A single parted line could no longer cascade into a failure. Chafe gear went onto everything that moved. Crews prestaged spare whale sections in sheltered pockets, ready for a lift on an hour's notice. Breakwater gaps were tuned with short blockship placements to spoil the worst cross-sea without strangling circulation. Where a spud leg showed a habit of sticking high, crews greased racks and adjusted guides before the next blow. None of it guaranteed survival. Each change bought margin. Port Winston's continued output cushioned the strategic shock of Omaha's loss. It kept divisional artillery schedules on track, fed forward dumps, and made room in the anchorages for more convoys. It also bought time for the Americans to rework their beaches. Direct unloading returned with stricter control of tides, better causeways, and more dozers ready to pull stuck vehicles clear on a shouted signal. The storm had shown what could break. The surviving harbor showed what could bend and still deliver. The race to rebuild capacity on the U.S. front accelerated. The morning after Mulberry A was abandoned, the beaches did not go quiet. Crews turned to the oldest port in the world, the tide. RHINO ferry, a powered steel pontoon barge, teams formed up alongside LSDs lying offshore. The promise was simple and hard: keep the Army fed with open beach methods. Tideworking became doctrine. Ships beached at high water, unloaded while grounded, and refloated on the next tide. LSD skippers practiced how to dry out, ground deliberately to sit on the sand at low tide, without twisting hulls or digging their own traps. They learned to read scour holes, pits eroded by propellers or current, and to avoid them by favoring firmer sandbars and gentler slopes. Bulldozers carved graded ramps at premarked exits so bow ramps met solid ground, not slurry. Engineers emplaced T-section pontoon causeway, a floating pier with a T-head sections anew, anchoring them in pairs where the surf permitted and accepting they might need to move after each blow. The goal was not permanence. It was a set of repeatable moves tied to the tide clock. RHINO shuttled loads when surf made direct approaches risky. The ferries, built from welded pontoons with outboard power units, took vehicles and pallets off LSDs standing in deeper water and ran them to the dry beach face. They were blunt, square, and forgiving. A damaged corner did not stop a day's work. A fresh panel and a new pin did. Beachmasters tightened control until every lane felt like a rail yard. Signal panels and Aldi's lamps assigned berths and warned of hazards. Chalkboards outside canvas headquarters listed tide windows, surf states, and the next 3 hours of arrivals by hull number. Dispatch points sorted convoys, staging ducks, trucks, and cranes so a cleared lane stayed clear. Convoys from England were rescheduled to meet the new rhythm. Escorts paced them so landfall came in daylight and on a flooding tide, not at midnight in a rising wind. If a front moved faster than forecast, anchorages redistributed ships rather than stack them off one beach. The tide table became a resource plan. Salvage crews made room for order. Divers, riggers, and bulldozer teams cleared wrecks from surf lanes and cut loose twisted pontoon sections. They dragged stranded craft above the next high water mark or opened them with torches and let the sea finish the job. Every cleared hulk removed an eddy that trapped sand and warped the next approach. LSD skippers drilled details that looked small and mattered. They dropped stern kedges, anchors set astern to control position, before going in, then used them to keep bows square to the beach as the water fell. Engines idled when rudders no longer bit, to spare the bottom and avoid fresh scour. On firm ground, a grounded ship became a stable dock for hours, not a liability. Cargo handling split by what the surf punished least. Ducks focused on lighter loads, rations, boxed ammunition, radio spares, and medical pallets that tolerated spray. Heavy vehicles and artillery rolled ashore from LSD bow ramps, then climbed the bulldozed exits under their own power. The sequence reduced the risk of broaching and kept the surf zone free of slow movers. Fuel followed its own track. Hoses ran from coasters beached in controlled laybys, designated beached berths off main surf lanes, to shore tanks and forward dumps. Handlers monitored pressures by gauge and by feel, a hand on the hose skin as pulses ran. When the tide forced a shutoff, valves closed in minutes, and the lay-by cleared for the next hull. Ashore, dumps reorganized by commodity and urgency rather than unit. Pol, petrol, oil, lubricants stood apart from ammunition by a safe margin and an extra berm. Fast-moving items were stacked nearest the exits. Slow or bulky stores went deeper. Dozers chased ruts, laying brush, matting, and fresh sand to keep tracks passable after each shower or tide surge. By early July, Omaha and Utah together moved daily tonnage on par with their pre-storm outputs. The names on the berths changed and the paperwork shifted, but the net was clear on the scales. The practice of the tide delivered what floating roadways had promised. The beaches breathed again. Utah's approaches, tucked behind the Cotentin, took a larger share of the heavy lift. Its gentler surf and firmer bottoms rewarded LSD crews who had learned the new drills. Heavier guns and tank transporters made their landings there on more days than Omaha could offer. Traffic then bent inland to rejoin the highway grid. By late July, the U.S. beaches surpassed Mulberry A's intended capacity using open beach methods. The pivot reduced dependence on fragile floating roadways under swell and put risk where it could be managed. timing, training, and ground preparation. The methods looked rough. The metrics said otherwise. Risk management improved because every shortfall had a name. More anchors were pre-laid on known approaches. Their positions were charted and marked by day shapes and night lights. Weather watches sharpened, with beach stations logging wind shifts and pressure falls, and relaying them to convoys still hours out. Evacuation drills emptied surf lanes in minutes when a squall line darkened the horizon. The system stayed flexible by design. A damaged causeway section could be cut out and replaced in a tide. A grounded ship could become a pierhead by choice, then refloat on command. When one exit bogged, flags and guides swung traffic to the next without waiting for a memo. With the beaches stable and the daily ledger back in the black, attention moved to the problem that never left planners' boards. A real port meant sheltered berths in any weather and railheads a crane length away. The drive inland now aimed at opening one. In Cherbourg's shattered outer harbor on the 27th of June, engineers walked past broken cranes and ragged quays. The city had fallen the day before, but the port lay booby-trapped and blocked. Without a working harbor, the advance risked outpacing its fuel, ammunition, and rations. The next weeks became a race between wreck clearance and a moving front. German demolitions had been thorough. Locks were blown, basins mined, and moles, long protective piers, breached to let swell into the inner docks. Scuttled hulks choked entrances and fairways. Divers mapped hazards while salvage masters cut, blasted, and lifted. By mid-July, the first Liberty ship, a standard wartime cargo ship, berthed under jury-rigged cranes, makeshift repairs that restored function fast. Significant flow followed only after more weeks of dredging, patching, and makeshift power came online. In that gap, the beaches and Arromanches carried the weight. Port Winston's reduced but steady cadence took coasters and LSDs day after day. Omaha and Utah drove tonnage by tide timetable and control, not by elegant hardware. The storm had not ended the seaborne bridge. It had forced it to diversify. When a front rolled across the charts, work shifted to the sector with the best lee. Mulberry's failed became a convenient myth. The record was mixed, and the nuance mattered. One mulberry broke under a long gale in a poor sight and against a mobile seabed. The other, placed in better ground and shielded by bluffs, proved indispensable through summer and into autumn. Arromanches absorbed American loads when Cherbourg lagged and freed escorts and convoys from risky anchorages. Design lessons hardened into doctrine. Site selection was not a map exercise alone. It depended on seabed character and exposure to prevailing swell. Omaha's mobile bars scoured under pressure, undermining legs and toes. Arromanches, chalk and firmer sand slowed that process. Hardware mattered, but where it sat mattered as much. Breakwater geometry and gap placement now emphasized bleeding cross-sea while protecting moorings from sage, a standing wave in a basin. Mooring design shifted from peak strength to endurance. The storm taught that 3 days of hard cycling could break what a single gust could not. Plans called for more legs on wider spreads, better swivels, and aggressive chafe protection on every contact point. Engineers added scour mats, fabric or concrete mattresses that shield seabeds around caisson toes. Spare pins, hinges, and fendering moved from nice to have to frontline stores. Operations distributed risk by default. No single pierhead or causeway was allowed to become a choke point. Tides set the master schedule. Beachmasters slid ships between sectors to keep hulls working and surf lanes clear. Evacuation drills were timed and repeated. When seas rose, crews preemptively stripped whale spans, lightened the stressed berths, and positioned tugs and kedges. A shackle, a U-shaped metal coupling that failed in a blow, became a checklist item the next day. Forecasting limits in 1944 forced practical measures. Without satellites or buoy arrays, local watches logged wind shifts and pressure falls and relayed them to convoys still inbound. The idea of storm posture took form. Lower loads on pierheads, stow lines, and pivot to RHINOs and tideworking before thresholds were crossed. Mooring plans embraced duration by counting cycles per hour and setting safe hours in a given sea state, not just safe maximums. Sacrificial gear was planned, not improvised. The human factor made all of it real. Seabees and Royal Engineers rewrote procedures between tides and shared fixes across national lines. Beachmasters standardized panel codes and lamp signals, so a skipper saw the same language at Omaha and Arromanches. Salvage units earned a new status. Their cranes, divers, and cutters were recognized as throughput generators, not rear area luxuries. The result was not frictionless. It was resilient. By August, Cherbourg contributed, but the beaches still mattered. Brest fell in September, but its port lay wrecked. Antwerp was captured early that month, and its estuary remained blocked until late November. The armies advanced regardless, fed by mixed methods. Arromanches on fair days, open beaches by the tide, and ports as they thawed from sabotage. By autumn, Port Winston still berthed ships, a reminder that a prefabricated harbor could endure when matched to place. The strategic consequence sat in the daily ledger. The supply line held. Divisions received artillery ammunition on schedule, and fuel dumps kept up with a breakout across bocage and into open country. The campaign's logistics proved that redundancy was not waste but insurance at sea and in surf. Weather remained the most ruthless adversary of maritime logistics. The answer was not bravado. It was options. White surf hammered steel pontoons off Omaha as cables screamed, and the American Mulberry broke, but the supply line did not. Arromanches held behind its bluffs, repaired fast, and kept lifting cargo. The U.S. beaches pivoted to tidework, RHINOs, and deliberate beachings, turning timing and ground into tools. The plan bent instead of snapping, spreading risk across one surviving harbor, open beaches, and the slow revival of shattered ports. Throughput dipped, then steadied, and divisions still found fuel, rations, and ammunition when they needed them. In the end, the Channel storm destroyed a harbor, not the invasion's logistics, and the image that opened the crisis closes it. Surf beating steel at Omaha, the noise of strain giving way to the rhythm of a system that learned, adjusted, and kept the army moving.